Hey friends, welcome to the Adventures of Blink. I am of course Blink and you can find me on GitHub right here. If you find this content useful, helpful, or fun, make sure you give me a thumbs up. And if you want more things like it, make sure you click that subscribe button as well so you won't miss any future episodes as the season rolls out. Now, speaking of this season, we're on a DevX deep dive. We're looking at common occurrences within the everyday lives of developers that will lead to bad experiences later on. So last week we looked at a README, and we noted that the installation instructions were more complex than we'd like to see. In the actual README page, there were multiple instructions to follow and a lot of detailed things to keep track of. We eliminated some of that complexity when we were writing the README by waving it away as we're going to write a setup script, and that's what today is about. A setup script has a single purpose. It's to be the on-ramp for someone who's learning how to use a codebase. Your goal is to automate as much of that installation as possible so that they don't have to overcome a barrier before they even get started trying to figure out how it works. We want to make it easy to run. Now, anybody who's ever written code before knows there's two ways to do that. You can do it quick and dirty, or you can do it clean and complete. Let's take a look at quick and dirty. Well, you might think, hey, that's not too bad. It's not a lot of code. It installs the app, it configures the database. When you reach the end, you're all set up. So what's the problem? Well, here's what you need to be thinking about. What happens if you don't reach the end? What if something goes wrong in the installation? You as the application builder probably know how to fix those things. You know how to adjust if there's a weird error that happens during the startup script. You can go comment things out or rearrange stuff and fix it, and it'll be just fine. But you aren't the audience for this setup script. The person you're creating this for doesn't have a clue how your application works, doesn't know anything about how it's set up. So you're going to need that clean and complete approach to this script in order to help them untangle themselves. So what are some things we need to improve within our setup script here? First of all, there's no error checking. We're just kind of running through the steps and assuming everything works, and if anything goes wrong, there's not even a chance to go clean up after ourselves. That could definitely get in our way in the future. Another thing that bothers me here is that we're using pip install there on line 5, but we've just finished installing Python, so there's a chance that pip isn't actually on this system. We should be running that as python-m. So that we're calling pip from within the Python application just to protect ourselves in case they haven't bothered to install pip separately. While we're on the Python topics, we don't have a virtual environment set up here. We should always be working in one because we don't want to leave a mess on their workspace. When you install a bunch of libraries, you can start to get collisions with things, and that's the purpose of virtual environments, is to compartmentalize things so that we're protecting ourselves from using libraries we don't expect, and we're also protecting the rest of the things. We're playing nice in the space. It's about stewardship, really. Another concern here is that we're not handling OS or package manager differences. So unless you're using a Debian-based Linux, this script probably won't run perfectly for you. There could be problems, and so it's going to be important to get ahead of those things. We're prompting for super user things within the script. A lot like a sudo command there on line 4. That could become a problem because it's going to interrupt the flow. You're going to kick off this script assuming it installed everything, and then it stops to ask you for permission for things. So we've got to figure out a better way to handle that. We're doing an export of db_URL. That's going to be temporary, and it's going to be lost after the script ends. So either we have to figure out a way to make it permanent, or we need to do without it. It's a matter of making good design decisions, right? There's no user guidance in any of this. There's no context given. All you see is starting install and done. And anything that breaks in between, we don't know how far we got. So that's going to be really important for us in the process of troubleshooting, to be able to leave ourselves breadcrumbs to find our way back through it. So I've been dancing around a vocabulary word here for several of these ideas that I want to introduce to you, just so you've got it in your pocket for having a fun discussion someday. The term is idempotent. Idempotency refers to an operation that can be applied multiple times without changing the result beyond the initial application. So you might think of this in terms of like a programming command that says x equals 5. Every time you run that command, you can run that 1,000 times and x will always end up at 5. On the other hand, if you had the command x equals x plus 1 and you run that 1,000 times, it will not end up with the same value every time. You'll get 1,000 different answers. And so x equals 5 is an idempotent statement, where x equals x plus 1 is not. So keep that in mind. We want to think about that in terms of our setup script. Our setup script should be idempotent in that when we install the application is installed. And regardless of how many times we reinstall it, it will always end up at the installed state. All right, so let's start working on our after version here. I'm going to basically start from scratch, and then we'll go back and compare and contrast afterward. So the very first thing we'll do here is to set this up again as a bash script. And the first command I'm going to add is set EUO pipe fail. Now this is about the strictness of our bash prompt. We want to ensure that it behaves in a certain way. So set E is going to instruct bash to immediately exit if any command has a non-zero status. So if we issue a subcommand from this script to call something else and that fails, we want to fail at the same time. We want to always end at the same, like any place that we encounter an error. We don't want to suppress any of those errors. The U command within the set affects variables. And what we're doing there is making sure that any reference to a variable that we haven't previously defined, with a couple wildcard type exceptions, will be an error. And so the idea here is, if I named a variable capital X and then I referenced it as lowercase x, bash would allow that to happen. It would just assume that my lowercase x is not defined, so it's null, and it moves on with life. But when we set the U option here, what we're telling bash is, if you don't find a variable by this name, it's an error, so you need to stop immediately. So the last thing in this set command is an O, and the O comes with a parameter of pipe fail. And whenever you set this value, what you're telling bash to do is, if it sees a piped set of commands, like for instance, I could do something like this, and this probably wouldn't work in reality, but it's the idea that we're doing, that kind of setup where you have multiple commands that are sort of piping their outputs into each other. If there's an error early in this pipe someplace, it will get glossed over because the future commands will see the error condition and sort of suppress it, and they'll mask the problem. So what we're doing with the O pipe fail is saying anything that happens, instantly fail on that, so that we can see that return code come back and it won't get masked by the future pipings. All right, carrying on now, the next thing we're going to do is add an echo statement so that we can keep up more information about what's going on with our script. So setting up your development environment. And we're going to sprinkle a lot of these kind of things through here, because the more verbose it is on the screen, the more you have to follow along if something terrible happens. So the next thing we're going to do is we're going to check for Python. So if we don't find a Python command, instead of trying to install it for them, which wouldn't be very idempotent of us, we're going to simply tell them this is a problem. You might look at that and think, hey, that's really not friendly. I should just take care of it and keep things rolling. But what we're doing is coaching our future users on how to do this setup themselves to some extent. We want them to have the prerequisites in place. We want them to have an idea of what's going on with those installations. The only things we should be messing with are the configurations of our application. So we're going to throw that out there, and then we're going to exit with a 1, just to let them know something failed, right? And so we're going to move on from that. And the next thing we're going to do is create ourselves a virtual environment. So we've now assumed that Python is ready for us. And so we're going to come in here and we're going to do, oh, I think I had an extra space there, -d. So if we have that command available for us, then we're going to do echo creating a virtual environment. And if you really wanted to be fancy with this, you could actually put the command out here for them so that they could see Python 3-m venv. There we go. And so we'll actually run that command next. And notice that we've made these neat little if blocks around everything. We're now controlling when things happen and having some understanding of where we are. So once you've created one, you have to engage it. And so we'll do this. All right. And now we're going to follow up with, let's see. We always check to make sure pip is upgraded. It has a tendency to be out of date. Okay, so the next thing we're going to do is install our app's dependencies. So we'll come down here and do if a file named requirements.txt exists, then, or if it doesn't exist, I should say, then we're going to do requirements.txt not found. And we'll exit with an error code there. Otherwise, we're going to install our dependencies. And this is just pip install -r requirements.txt. Okay. Now, if you think back through this, we had some stuff where we were setting up our DB URL and such. So let's take a look at how we do this. We're going to set up an environment variable using .env. So if, let's see, we should have a .env file, but if we don't, then we're going to create one. And in the process of creating it, we should always let them know that we're doing it. Create a file. Okay, and then the next thing we're going to do is load that file. Now we're going to migrate the database. Okay, so obviously we're making some assumptions about how this works. We're assuming that a manage.py file exists within our app and that it has a migrate command associated with it where we can just call it directly like this. If your app doesn't have that, then you need to think through the process of how to do that automatically. And writing a little Python script to do the migration really seems like a useful thing here because I can call it with a one-liner as part of the process of installing. Okay, so obviously as we're doing some of this, the app doesn't exist and it's going to be a little weird, but let's imagine then that you had a script to create a super user for the database. And so you would do python manage.py create super user. And it would build all that out for you. And then we are now ready to say setup complete. Activate your environment with all right, there you have it. So we've now written out our script to take care of all the things that appear in here. Oh, I guess I should keep my names consistent between the before and after, shouldn't I? Okay, and there you have it. We've now finished our script. So if you take a look, you'll notice this is a little bit longer than the one we had before. We went from 9 lines of code up to 45, but there's a reason for it here. And it's odd to think about because last week we ended up making our README better by being more concise. But this week, better means adding detail. And the difference is whether it's in the code or the documentation. Your docs shouldn't really be cumbersome. They should give you what you need and nothing more. But your scripting should always be meticulous. You should always have more echo statements. You should have more, one thing I didn't do in this process was actually write comments into the script. I should have been commenting my code along the way. That'd be easy to go back and add since it's only 45 lines, but you get the idea. That's the kind of thing that we're looking for. So that wraps up this episode of The Adventures of Blink. Make sure you tune in next week as we continue our DevX deep dive, and we're going to take on a broken and buggy test runner. See you next time.